For the second lab, I will be describing the motion of a falling object. The object I chose was a styrofoam cup because it is light enough to experience drag. Unfortunately, the cup spins, so the tracker data is a tiny bit skewed. For my observations, it is simple. The cup starts at the top, and in tracker I put the origin so it starts at the top, and it goes straight down in the negative y direction. At the top, it starts slow, and due to gravity, it speeds up, so at the bottom, it's going pretty quick. And here's my graph. In using the model with just gravity, it is not the same, and the gravity is the gray one, and my observations is the orange one. And the reason the gray one goes down so much faster is because something is speeding up, or something is slowing down my observations. And that something is drag. So drag is where I put in the blue one, the blue line. And that slows it down to almost match my orange data pretty nicely. And so now I'll show you how I made these lines with the models. And that resemble my observations. So we always start with the fundamental principle. So using Newton's second law, I described the velocity in the y direction, and then since the velocity is not constant, I had to describe the net force, and the net force has two forces included in it, and it's the weight force, so mass times gravity, and drag force. And the weight force is in the negative y and the drag force is in the positive y direction. And drag force can be described by the math that I inserted into my code. Fd equals b times the magnitude of the velocity squared times j hat, which is the direction. And for b, you kind of have to guess to see what matches. And it turns out that my B was 0.00536. And so Newton's second law and the net force was really the only physics that I had to change in my code. And other than that, I added the mass, and the mass of my object was 0.0044 kilograms, which is very light. And I added the arrows, so the arrows was mostly in the starter code, but I had to change the arrow scale to actually show the arrows, and then it's all in that picture. And then the code runs just like this, which looks just like my observations, where the cup just goes straight down, but in my code it's a ball. And in terms of the terminal velocity, the model with the drag includes a terminal velocity, and if you throw the object straight down, it doesn't change the terminal velocity because the net force would change based off kind of the time. So I changed my model to have an initial velocity in the y direction, and the terminal velocity didn't change as long as I made the time longer, because it takes time to adjust for to get to that terminal velocity. So thank you.